How does a computer recognize an object in an image? When we see this image, our brain instantly recognizes a face. But for a computer, this image is nothing more than a collection of numbers. So, how do neural networks actually understand images? The answer is convolutional neural networks, or CNNs. But before we understand CNN, we first need to understand why traditional neural networks fail when working with images. Let's first understand how a computer represents an image. An image is made up of pixels, and each pixel has a numerical value. For grayscale images, the value usually ranges from 0 to 255, where 0 represents black and 255 represents white. So instead of seeing a face, the computer actually sees a matrix of numbers. When we want to use a neural network for image recognition, we need to feed these numbers as inputs to the neural network. How do we feed this into a neural network? Imagine we have a typical image that is 1000 by 1000 pixels. If the image is colored, it has three channels: red, green, and blue. 1000 multiplied by 1000 multiplied by 3 results in 3 million input features. That means our neural network would need to input 3 million input features. In a fully connected neural network, every input is connected to every other neuron in the next layer. This creates an enormous number of parameters. First, this requires massive memory. Second, training becomes extremely slow because we have a lot of parameters to train. And most importantly, the model can easily overfit the training data. How do CNNs solve this? If you see on the left side, we have traditional neural networks. So traditional neural networks treat images in a very strange way. They first flatten the image into long list of numbers. A 2D image becomes a 1D vector. You can think of this like putting the image into a paper shredder. Once the image is flattened, the network loses all spatial relationships between pixels. The network no longer knows which pixels are neighbors or which pixels belong to the same object. But in images, spatial structure is extremely important. The shape of a shoe, the outline of a face, the edge of an object, all these depend on how pixels are arranged in space. Convolutional neural networks solve this problem in a completely different way. Instead of shedding the image, CNNs behave like detectives. They scan small regions of the image and look for meaningful patterns like edges, corners, textures, shapes, etc. By detecting these small patterns and combining them across layers, CNNs can recognize complex objects in images. So traditional networks shred images and overfit. The solution is the CNN, which acts like a detective, scanning for patterns instead. But how exactly does this scanning work? In the next video, we will dive into the core engine of CNN, the convolution operation. We will see how filters slide across an image, how they detect edges, and how we handle RGB colors. By the end of this series, we will put all of this theory into practice and build a complete CNN from scratch using PyTorch. Hit subscribe and I will see you in the next video.